So hi everyone, I'm really excited about this session. We are glad to have you on board. This is the Spatial Data Science session that's being run by Linda Beale. So before we get to that, I want to take us through what Women in GIS is for a couple of minutes, and then we can get to looking at the actual why we actually here. So this is part of our After Office Hours session that is we run it as Women in GIS Kenya. And the main, today we are going to focus on ArcGIS Insights and also going to be shown how to extend that using R and Python. So for those who are really new to ArcGIS Insights or have never heard of it, this is actually the right platform. We're actually going to discuss that and actually do a couple of analytics with Linda. So for Women in GIS Kenya, the aim of our initiative is we mainly aim to bridge the gap between the gender divide within this space, and we drive inclusivity within geosciences in the Kenyan space. Some of what we do is social gatherings, which has definitely been stopped due to the pandemic. And then we also do professional development, trainings with universities, networking and mentorship. So those are our key activities. And now we introduced after office hours in March, which was the first COVID case we had in Kenya. So that's why we shifted to after office hours sessions to just ensure that we are still building a vibrant technical community amid this pandemic. So that's the main inspiration behind the after office hours session. And the other thing is also we got the term from the fact that we're actually running the session after work. So normally closure of business is at 5. So after that, we decided to just call it that, since it's an after work session that we aim to build the capacity of local people and also globally build the skills of our community. Yeah, so that's it for the introduction. As we go on, after Linda's session, we'll also talk about what's next after this particular session. So thank you so much. I'll hand it over to Linda. So the session is also being recorded for the purposes of everyone who's in this session. And then as we go on, we'll also take a couple of pictures. So if you're probably uncomfortable with that, you can maybe turn off your camera, but we'll also be posting the pictures that we'll take here on social media. And then the hashtag for the session is ArcGIS Insights. So thank you so much. I'll hand it over to Linda. We'll also be taking questions on the chat section, and then feel comfortable to paste that. And also at the end of the session, you can unmute your mic to just ask also the questions after Linda is done. So thank you so much. I'll hand it over to Linda. Linda, we are so excited to have you. Yeah, take it away. Thank you so much for agreeing to do this.
Yeah. Well, thank you very much for inviting me. So I will share my screen. If you stop sharing yours. Okay, there we go. Okay, so I'm going to start with just a few slides just to kind of level set what Insights actually is. My name's Linda Beale. I work at Esri. I'm the group lead for location analytics, and Insights is one of the products that fall within location analytics. The idea of that is to allow people, or location analytics as a whole, is to allow more people to have access to GIS, and in that way we try and make it as user-friendly and accessible as we can, and we want spatial analysis to be a part of all of the analysis that we do. So it's a component of the data that should be used. So within Insights, what we do is we try and do everything visually. For those of us who've worked in GIS for many years, you know, we love the map. We love working with what we see, and we're extending that to all parts of the analysis. So you can connect to lots of different data types. You should be able to visualize all of the results that you have, but it's also important that you quantify what you can see. So we make sure we add in statistics with all of the visualizations that we create. And as we've already heard, we allow you to extend that kind of exploratory analysis, connecting with Python and R, so you can move into that scripting world and have complete control over how you do your analysis within Insights as well. So within this self-service visual analytics that we have, what we do in terms of how it works is wherever possible, we try and send the computation to the data. So that's a little bit different to how a lot of GIS works. What that actually does is, I mean, this is kind of getting into the technology a bit, but it's important that we understand how our data is being used so that we can work efficiently with that data. So normally what we do is we process data within the memory of the machine. So you could only do your analysis as good as the machine is that you have. Whereas if we're sending our computation to where the data sits, then it means as long as you have either a good database or a good data store on that machine, then you can send large pieces of information, or sorry, you're sending that computation to that data, and very often the results you get back are much smaller. So it can be a very efficient way of working with that data. We can join lots of data sets. We do join slightly differently to a lot of sort of GIS ways in that we don't actually flatten out the data. So that means that we can do one-to-many and many-to-many joins. Again, another way of working efficiently with data. So we don't have big flat tables with lots of null values or missing information within that data set. We also allow you to store your data with multiple shape fields. So I'm guessing all of you work with GIS pretty much all the time. We know that every layer has a shape field, a geometry within that, and it will either be a point, line, area, or a raster data set. Well, within Insights, we only work with vector, but you can store those multiple shape fields. So I could have an individual location of that data. I could also tell you what ward that data sits in. I can also tell you what county that data sits in, and all of those are a shape field within that data set. We can do that because we allow you to geocode your data on the data sets when they come in. So that's a kind of an additional thing that we do within Insights. So what are the key features of Insights? Well, we kind of covered it. We allow you to work with lots of different types of data from many different data sources. So you don't have to put all your data into one type. You can bring it in from multiple different sources. The idea is that you analyze that data within it and that you get sort of a visual picture, a visual understanding of what that data is, as well as being able to quantify those results that you see. And as I've mentioned, extending it using Python and R, and extending it in terms of being able to do the coding against it, and also being able to bring in the visualizations that you can create within both Python and R. So just as a sort of a background as to what Insights is, we work within workbooks. We have our data pane on the left-hand side, much as you'd expect within any GIS. The results that we see are visualized on cards, and we also have something called an action button on our cards when we can get to additional analysis. But we try and keep the UI very clean. The idea is that you should be able to work directly with that data, and we'll explore this as we go through it a bit this evening. So deployment and the data that we have, again, just giving some background here. So ArcGIS Insights works on Enterprise, on ArcGIS Enterprise, on ArcGIS Online, and we also have a desktop version that you can download. And obviously with the desktop version, you can connect to your online or your enterprise setups, depending on which one you have. And that's not an additional feature. It's if you have an online or an enterprise account with Insights, you will have the ability to download a desktop version with it. We connect to all sorts of different data. So obviously the GIS ones, feature layers, geodatabases, shapefiles, GeoJSON. You can also directly bring in Excel and CSV files. We allow you to connect directly into databases. So you don't have to take data out of a database, put it into a geodatabase. You can connect directly to that database. It doesn't have to be spatial data, but if it has spatial tables in there, obviously we work with those. So you see we work with SQL Server, Oracle, PostgreSQL, PostGIS, and SAP HANA. In terms of Python and R, we connect to Jupyter Notebooks. I'll explain a little bit about how that works later on this evening. And so we allow you to bring in your Python scripts, your Python notebooks, and your R scripts. So how do we work with the visual analytics? So again, slightly different from how we work traditionally with GIS, where we by standard will select the layer of interest. So you put in the layer you're interested in, let's say your roads, you put that on your map, And then if you want to visualize those roads by the amount of traffic on them, you then select that as your symbology, or you open your data table and you see that attribute within your data table. Within Insights, you work directly with that piece of information that you're interested. So following through that same example, if I want to see the amount of traffic on my roads, I would take the field, the attribute that says traffic, drag that to my map, and that will immediately visualize it by the amount of traffic. So it's just flipping it on its head a little bit. Rather than going from layer to attribute, we go directly from attribute to visualizing. So it's just a case of thinking, what is the question I'm asking of this data, and then working with that piece of information. It works very much through drag and drop. So rather than having to distract you from your visualization by filling out a set of parameters as what you want to do, you take that piece of information that you're interested in and you drag that to your map, your charts, your tables, and then you're immediately able to visualize that information. So this is our little guy, Dr. Drag and Drop, to remind us that we're dragging and dropping. I always put that in there so everyone can do a big sigh. And then, of course, the key thing within any analysis is interpreting what we're seeing. So really what we're trying to do within Insights is give you more time for number 3. That's the most important part of analysis, is interpreting what you're seeing. And of course, it's iterative. As we start to see things, we will maybe change the questions we're asking. It may give you more questions that you want to ask. So that's really the key thing, for us to step through 1 and 2 as quickly as we can. And what we're trying to do is make the technologies that were kind of fade into the background. You already have a full-time job doing your analysis. What we're trying to do is allow you to get the most out of your skills as analysts without having to worry about learning the technology. Because it's that skill of asking the questions and interpreting those that's what makes analysts something really special, because that's the key thing that we do, knowing how to pull information out of just pieces of data. So data-driven analytics is how we help that process. So when you bring in a data set, we actually semantically model that data. What that means in everyday terms is we look at the type of data it is, and then we know, based on that type of data, what kind of analysis you can do with that piece of information. So we can do different things with strings and numbers. You can't add up strings. Well, we know that if we've looked at it and we said, okay, this is a string, or this is a number, or this is a date time field, or this is a spatial location. So based on that piece of information that we have, when you bring in your data set, we are then able to say, these are the options that you have to work with your data. Again, it's about making it convenient for you as the analyst to know these are the things that would make sense with that type of data that you can carry on. Sometimes that's actually going to help you understand that there may be data errors within your data, because there are times when you would be thinking that that piece of data is a number, and within the CSV or the Excel file or something, somebody's put in a hyphen that says there's no data, and as we bring that in, it's going to be interpreted as a string. Well, you're immediately going to see that, and then you can go back to the data before you've gone down a long line of doing your analysis and then realizing you're actually missing perhaps a piece of information within that data. So the action button I mentioned. So a lot of it is about drag and drop analysis. You can just drag the pieces of information. You will immediately see a visual. You can interpret that. But in some cases, we do need some input. If you have multiple layers and you want to, I don't know, let's say we want to create buffers around those areas, which layer is it you want to create that buffer around? You're going to need to give that input to us. In that case, we're going to pop out a little menu that allows you to fill in those parameters and then run that tool. So there's a lot of extra analysis that's available to you from the action button. That action button will appear on any of your map cards or your chart cards so that you can access them. We also have this ability to find answers. So there's two tabs on this action button. One is for spatial analysis functions and one is called find answers. And again, that's to help you. So they're not necessarily spatial, they're not necessarily non-spatial, but they're the kind of things that you can do within Insights that will help you understand those questions. So for example, if you want to understand the distribution of your data, something as simple as classifying it on the map might be useful, or you may want to look at that numeric distribution, in which case you might want to look at a histogram or a box plot. So again, we're helping you know how you can pull the best out of that data. Whenever we do our analysis, we also record everything. So this is done automatically for you. So we're actually creating the models, the workflows that you've done to get to that analysis. At any stage, we will be showing you exactly the steps that you need to take to get to that analysis. So you will see this workflow model has been recorded on the back of, on the back of every page. So you switch to the analysis view and then you're able to see that workflow model. So again, I'll show that in just a second. It also allows you to see all of the steps that you've taken. So if you've added filters and things into your data, then it will show you how to get back to that by showing you the exact steps that you took to get to do that analysis. So now I'm going to stop talking about it and actually show it. So can I just confirm, somebody just confirm that you could still see my screen there with Insights on there?
Yeah, you can still see your screen.
Perfect, thank you very much. So now we're looking at Insights itself. So this version I have is working on ArcGIS Enterprise. It's exactly the same whether you're working in Enterprise, desktop or online. They look exactly the same. It's the same code base, so there's no difference there. So I am going to start from the very beginning just to show this is how we can start with our analysis. So I'm going to go to the European CDC web page here and I'm going to download today's data set on the COVID-19. I'm going to open up a workbook that I have and I'm going to upload that data set I just downloaded there. So you see it's as simple as just dragging and dropping that file in there, add it in, and now you'll see I have essentially that layer, as we would know within GIS, has been added to my data pane. We like to call these data sets because, as I say, it doesn't have to be spatial. And in this case, as we know, this was an Excel file that I just brought in, and it's non-spatial. How do I know that? Because all of these little icons that we put on here are part of that semantic modeling that I said we do. So I know that this is a temporal field, I know this is numeric, and I know that this is categorical. When we bring in a date, time, or a date or a time field, we will give you those additional components. So these date components, we automatically calculate those for you. So within this original data set, there was one field called date rep, but we've added in these little pieces because very often I'm asked things like, well, how many times a week does that happen? Or how many, does it happen always on the same month? So by us giving you that date component, it means it's much easier to actually jump in and analyze those different features. So now we can just get going with our analysis. So do you remember I said, what are the things we're interested in understanding? So this is the COVID-19 across the world. I want to see if the number of cases and deaths are increasing over time. So if I take the date, which is the time, the number of cases and the number of deaths, I drag those and now you see that card popped up, and the only option I have if I have a temporal field is a timeline. So now that has given me that timeline of the number of cases and the number of deaths that are occurring across the whole world. I can zoom into this if I just want to see a part of that line. And now we get into, I can actually interrogate this card directly. So this is showing me the total number of cases and the total number of deaths. But what if I want to see this broken out by, let's say, the different continents? So now I can go onto that axis, so I can change any of these components on the axis, and now I can see that information by each of the continents. So you see how I'm asking questions on the actual card of what I'm interested in looking at. If I want to look at the total number of cases, and let's say I want to say by country. So if I just drag the number of countries and I have a look at it on, these are the types of charts that I can create. I can look at it on a bar chart, but that's going to give me the count of the number of events. In this case, it's probably going to be right because we're going to have a row for each one of these cases. But to be sure of that, I can take the cases and the countries, I can drop it onto a chart. By default, we make sure that the first visualization that you're given is always going to be a sensible one, but it's not always going to be the best one. And this is where you as the analyst can come in and start to think about what makes sense. There's a lot of countries in the world that have cases of COVID-19. So by the time we're seeing this on a bar chart, we're not really able to pull out a lot of that information. So maybe I want to think about, is there a better way that I can visualize this? So a lot of information on here might be more sensible for me to change this to something like a bubble chart. Now I'm picking out, I can see all of that information. I can see how many countries there are. The different sizes of those bubbles is telling me which ones are the largest, have the most number of cases, and the pop-up is giving me the details of exactly what it is. So you'll see with a single click here, I'm able to change those visualizations. So if I'm interested in just the top ones, maybe a tree map would be a sensible way of showing that. So again, each one of these is sized by the amount, the total number of cases. So now I'm able to pick out those top ones very easily, but I'm not so easily able to see how many they are overall. So all of these different ways of looking at this data is giving me a slightly different view on that data and a slightly different piece of information, that I can get from it. So each one of these different visualizations gives you a different picture of that data. And that's one of the features of Insights about exploring your data, is that ability to change between it. So I can change between any of these. Now at the moment my data is non-spatial, so I'm just creating the charts. I could create a table of that data, but what if I want to actually map that? Well, I can enable that location, so I can geocode that data as long as I have a piece of information in here that makes it spatial. Well, I do have the names of the countries, the names of the continents. So if I can bring in another shapefile or another layer, feature layer in this case, that will tell me that, then I can join those two pieces of information. So I've gone into my enterprise account, and as part of that, we do give out standard boundaries. So this is world data, so I'm going to look up the world boundaries, and I'm going to join it to the countries. So I just want to select out the layer that's the countries. So that's brought in my country data set. And now if I go in and enable that location, I can join that based on the geography. So you see I could do it on coordinates, address, or the geography. I want to join that based on the countries, and I'm joining it to the world country. So it's not got 100% match, but that's what I'd expect, because not every single country in the world has cases of COVID-19. So that seems right to me. And now I have that spatial component on my data. So of course now if I take those cases that I've been looking at and I drag those, you'll see that now I can create a map. So now automatically that's going to map all of those cases across the world for me, and now I'm able to see them. So I can also drag any other variables across from here. So I could be looking at it by the country. So if I drag that, it's a categorical variable. So now it's going to style that by the categories. So you'll see that styling that by whatever the piece of information, the attribute that I'm dragging. So if I want to look at deaths and cases on the same map, the way I need to do that is by creating another map. So now I have the number of deaths over here. Let me recolor one of these. So I can go into any of these, change the colors. So let's give that a different color there. And now if I drag this, so you see how we can work from one card to another, I can add that new layer. And now I have both of those on the same map. There's not going to be as many deaths, so I need to rescale that down. And now you'll see I'm able to visualize all of that information on one card. So now that starts to act very much like we would expect any map within GIS to act, and we can have any number of layers on that data set within there. So this is showing me the total number of cases. As I say, in terms of our defaults, we think carefully about it. So that's showing us the number of health events. That's useful if we want to look at prevention measures or the amount of healthcare. But in most cases, the number of health events can only really be understood in reference to the size of the population from which it's been derived. So in epidemiology, the rate is the frequency of events that occurred in a defined population over a specified period of time. And that's what's useful for us to understand health events, in this case across the world. So how do we calculate that rate? Well, we can go into our data table just as we would expect to within any GIS. I can calculate the rate. So I'm going to take the cases and divide that, cases, divide by the population. Let's multiply that by 100,000 just to get a number that's going to make sense. Run that, and now I have the rate calculated. So now we have the rate, and now you'll see how we can control this. So if I drag that rate, just as you'd see here, we would get graduated symbols. If I click on the actual icon, I can turn that into a rate ratio, because now I know the smart way to map that is to create a choropleth of that rate. So again, this is how we're able to work with the data, visualize that, and see the different rates across the country. So calculating rates, visualizing it in different ways. We've understood there the kind of the spread across the world. If we want to look at the distribution of the actual values, again, we could look at that on a chart in this case. So the standard way would be to create a histogram. Within health, we tend to have very sort of infrequent, rare events. So we have this very skewed histogram that we see. But now you'll see if I change on this info button, if we go to the back of the card, and this is an important feature within any of the analysis that we're looking at visually, is to check the values that we're getting. Are you seeing all of the data? Is this what you'd expect? And in terms of a histogram here, we're seeing the skewness of the data and the excess kurtosis. And we are seeing that this is not normally distributed at all. We would also be able to look at that visually. That's important because if we want to put anything like this into something like a regression model, which we can do here in Insights, we know that the data is assumed to be, the data should be assumed to be normally distributed. So we would know we would need to log or take some action when we're doing that analysis. So it's important, even just when we're sort of looking at this data quickly, to really have an understanding of what's going on in that data. If we want to look at it by a number of different, a sort of breakdown, let's say by countries, I could take that number of cases, and in this case, I'm going to look at it on a box plot. Now we're seeing that distribution by all of the different countries. That's quite a lot of information. We have a scroll bar that allows us to go through it, but I'm not really seeing an awful lot there. I can add in something like a filter card. So now with that filter card, I can find where it's been dropped. There it is. Then I can then select out that information using that filter card. So I'm going to add in by, let's say, by the continents. I'm going to have all of those continents in there. Maybe change this so that it is a drop down, just to keep it tidy. And now you'll see I'm able to just filter out to those countries that fall within the continent of Africa. And now I'm much better able to see that distribution within all of those. And what this is showing us is that cumulative total by a higher level of hierarchy. So I have the individual cases by day. This is then accumulating that information. So it's showing me that distribution by day. So what I'm able to see here, because I've broken it out by countries, is those dates, those periods when there were particularly high numbers of cases. And of course, we could do exactly the same. If I change that to deaths, you'll see now I'm seeing that pattern of those outliers, as it were, and this is going to be reflecting on all of those other cards that I've created. So that interactivity is automatically built in. So now I'm able to see when those events occurred and where those events have occurred across all of these different cards. So that then allows you to, when I was saying about analysis being iterative, to ask more and more questions of that data, because that's going to raise more questions within your mind. So that's getting going with insights. Let's have a look at an analysis here that I was challenged by Caroline a couple of days ago. So she sent me a data set on adolescent pregnancies in Kenya, and my understanding is, and I'm way out of my depth here in terms of understanding pregnancies in Kenya, but I looked at the data and that's what I'm going to report, what I've seen. And my understanding is that they're saying a lot of the pregnancies in children have gone up a bit. And the question is this because of the COVID-19 pandemic? So I took in that data. So I brought in a couple of CSV files. You saw how we can bring those in. So one of them was for 2019, one of them was from 2020. And what I did was I joined those two data sets together. So I joined those two data sets using this create relationships. So I took the 1919 and 2020. I joined it on the month. I also joined it on the ward. So that way I've joined it in both space and time, but excluding the fact that the year is different. So the same months and the same locations are joined together. That then created me this new joined data set that you'll see has all of that information is for the amount of pregnancies in 2019 and the number of pregnancies in 2020 by month.
Linda?
Yes.
Could you show one of the raw CSV files? I think people are sometimes interested to see what does the raw data look like.
Absolutely. So the raw data set of the January to May, let's have a look at that original data set that I brought in. So this is the original data. It has that data in there. It has the counties, sub-counties, wards, unique ID. Then this is the total number of pregnancies broken down by those two different age groups. I didn't know what this field was, so I haven't used it. And these are the date components that we add in. So do you remember I said right at the start, the original data has one date field in it, but we automatically give you this information. So we've broken out the year, the quarter, and the month. And these are, of course, of zeros because it doesn't have in there the month and the time. So those just have zeros in there. So those were those two files that I brought in join together on those. So remembering that this data has a row of information for every single ward and for every single month, we have that information. So that then enabled me to join that data. If you remember, we went through the enable location and I could join that based on the geography, and I joined that onto the Kenyan wards. So now I was able to map that and see those pregnancies for 10 to 14-year-olds. So now I'm seeing that spatial distribution. So if we take something like those, oh, actually I've joined it on counties. So I've joined it to the counties, so it's aggregated it up to those counties. But let's take the pregnancies for the 15 to 19-year-olds, and let's look at it by those number of counties. And I've got two pieces of information here. I'm going to drag that to a combo chart, as we call it. So this is putting two pieces of information on that same chart. I want to make both of them column charts because they're both, it's not continuous data between the counties. They both stand on their own. We can actually change that to county name. So now we're able to compare those differences between the total number of pregnancies in 15 to 19-year-olds in 2019 and 2020. If I just pop out that legend, we'll be able to much better see which year is which. So the black lines are 2019, the blue ones are 2020. Now this is for exactly the same number of months. So this is just January to May. So what's interesting in this is I was given the data set, I was told that there was the question as to why the number of pregnancies were increasing in 2020, particularly in February and March because of the COVID-19 pandemic. And yet I'm looking at this data set and all of the 2019 values are higher. So there's the odd one. I see that there are a couple of counties where the blue line is fractionally higher, but as a whole, I'm not seeing that. So this is the 15 to 19-year-olds. So I can change that to the 10 to 14-year-olds. And I want to do that for both of those years. So obviously the numbers are a lot less. And I want to make sure that I have both of my axes exactly the same here. So I want to synchronize those axes. Turn those labels off. Okay, so now I really am seeing that pattern that in 2020 there were a lot more pregnancies between the 10 to 14-year-olds. So this is really where we're seeing that difference in that data. So it's not the 15 to 19-year-olds, it's the 10 to 14-year-olds where the number of pregnancies has increased. It's not across all counties. So there are some counties when there is a significant difference. Now again, you know, as the analyst, you'll be interpreting that with knowledge. It may be that some of these places have not reported the correct numbers, or it may be a true pattern that you're seeing within this data that spatially there is a real difference, because we can see somewhere like Nairobi, there is a huge difference in terms of the numbers that you're seeing in 2020 compared to 2019. So we could look at the actual numbers on the data table here, and you'll see that we can see those differences reported. In fact, 15 to 19-year-olds we are seeing are lower in 2020, and yet in 10 to 14-year-olds we're seeing that those are higher. So I can actually quantify what we're seeing here using the action button. So to understand how that's been changed, I'm going to change that to that chart that I've created. And now I'm going to look at the 2019. I'm going to compare that to the 2020. Look at that difference. Run that. Again, what this is doing a calculation for you. So that's showing me that difference by each one of those counties. And you'll see here when I created that column chart here, it actually gave you a new data set. That's an important part of Insights, that it's giving you new versions of your data, new analysis that you can see. So now I can see that difference by county. Drag that to a new card. And now we're able to see that pattern across all of those counties, and we're able to see each one of those counties that has a much larger difference. So the ones that are the positive values have had an increase in terms of the pregnancies in 2020. The ones that are negative have seen a decrease between 2019 and 2020 over the same months at the start of 2019 compared to 2020. So there is something in the stories that the pregnancies have increased, and just kind of visualize that on showing a heat chart. So that's the start of the analysis, and you can see hopefully how quickly you can get going. But obviously this is just the start. This is now raising the questions as to where those locations are, which again you've seen through using the interaction between the maps and the charts. You could pull out where those were, and you can kind of drill down into what it is that's actually happening. So I wanted to show a little bit more about how we can do the analysis. So you may want to sort of take that and say, well, because the story is that maybe because they're not at school, because of the COVID-19 pandemic, that's what's caused it. So I've got a data set here of schools, and you could do a comparison of where there are more schools compared to where there's been an increase in those number of births. So one way that you might want to look at where there are more is you could do something like calculate density. That is going to show you that density surface of where there are more schools than other ones. You could then compare that to those locations. Zoom into that a little bit. And of course, as we'd expect, there's more around Nairobi and where there are more people. So that raises that next question, is this really telling me very much? In this case, I would say that's not really helping me answer that question. It's just telling me where there are more schools. And now I've got to go and do even more work to work out, well, how does that compare with where there are more pregnancies? So what we could do is calculate something like the density ratio. So I'm going to take that number of people, in this case I've just used people, but you would be using to answer that question, number of pregnancies, compared to the number of schools. No, the other way around, schools compared to the number of places, population, that's right. That's now giving us that comparison. So I'm putting in that denominator as to where is there more or less than I would expect. So it's not just where there's more, there has to be that kind of that understanding of compared to what the norm is. So you could do something like a regression analysis. Again, we do have regression within Insight. If you have other pieces of information that you would understand might be contributing to why, and that would be a useful way of doing that analysis. But this is going to give you that first look as to whether one of those features might be pulling out that piece of information for you. So this is running a density analysis for both the numbers of schools and, in this case, the amount of population, and doing that comparison between the two. So I can turn off those two layers by just clicking on the actual layer. I want to actually reclassify this, so it's going to really pull out those differences. So I'm going to use a natural breaks classification, and now we're able to see where there is that real difference in the number of schools compared to the number of the amount of population in this case, And now we're able to, you see, we're not just pulling out where there's more, it is that difference between the two. So that's a good start for that type of analysis, to understand where there's more or less than you would expect there to be. So that's running density ratio. And we could do other things like aggregating that information up. So with our points to our polygons, it's as simple as drag and drop, as I mentioned at the very start. So to aggregate up those number of places into the wards, you will see that that's now given me that total number of populated places by ward. So that's what I mean when I said about the drag and drop. It's very easy to get going with that. It's also, if you want to select out particular regions, I can select that county, drag that to the new card, and filter out by those areas. So if I just want to filter out those populated places, then that is just going to select out those areas from that layer. That's now just selected those areas. And if you were doing a different type of analysis, you can go in and have a look at trying to understand the clusters within your data. So if you want to find sort of equally distributed areas, so if you're looking at schools or something and you want to say which populations could access things equally in terms of distance, or if I wanted to bring in attributes, then I'd be finding those areas that have very similar characteristics within that data. But what I want to show really there is that it's not just about creating maps, charts and tables, but there is real strength of analysis that you can do with having already pulled out that piece of information as to where you want to look within that data set. Another feature we can do is what we call graph analysis. So this is finding those interactions, those relationships within the data. We can do this spatially and non-spatially. I think pretty much all of our tools work both spatially and non-spatially. So we could take these two coordinates. So this is the spread of COVID in terms of the actual strains. So this is going to show how those strains have moved across the country. And because I know it's the flow, I can change that to be directional. I can also visualize all of these different features on here by different components. So that's the different clade within the strains. And you can see where each of those has traveled from each of those countries, which is really helping us understand that spread across the globe. To say we can do that spatially and non-spatially. So I could take any of these pieces of information, like the clade and the country, and I can add that to a link chart, and that is going to show that spread non-spatially. Again, that will help us understand those interactions. So this is actually quite clever in the sense that all of these nodes, the size of them is showing you that importance of that relationship. So there are calculations going on behind the scenes that are working out which are those most important connections between, in this case, the countries and the clades, and where it's spread to between all of those different countries. Also allows you to do sort of tracking. So there's a lot of talk about track and trace. Well, we can do all that kind of features if you imagine that we're tracking individuals and we're able to see all of those either people they've met with or places where they may have interacted. You're able to do all that type of stuff within using this link analysis. So the last feature I want to talk about is data science. So I said at the start we can connect to Python and R. So we do that by using Jupyter notebooks, but slightly differently to standard Jupyter notebooks. We do connect to Jupyter notebooks. So it requires that you download them. Those are open source, so they're free to download. Nothing to do with ArcGIS or Esri. You download your own, but then what we do is we connect through this thing called a kernel gateway. But this is a Jupyter kernel gateway. So this allows us to then talk through to what are actually called the kernels in the back end. So your Jupyter notebook is actually the front end, the UI to these kernels. So what we do is we don't use the notebook UI. We use a UI that we've created within Insights, but we connect through this gateway and talk to those same kernels that you'd be using if you were using your Jupyter notebook. So if you're already using them, you don't need to change anything. You just need to set up this gateway, and we have a website that tells you exactly how to do all of that. So that website is on GitHub, so it's github.com/Esri, and it's the Insights-scripting-guide. So if you just do a search for Insights Scripting or Insights GitHub, you will find that just as easily. That steps you through the process of actually setting up that gateway, talking to those kernels, and then you're able to pass your data to and from Insights and do scripting within Insights and run those models on this gateway to use all of that functionality as well. So to show you how we do that, let me start up a kernel. So I'm going to do an R kernel, and let's create a data frame. So I'm going to just drag one of these data sets in. So that's going to create a data frame from that data set. So now I can type in my code, and I'm going to cheat by cutting and paste so I don't make a typo, and run that. So all this is doing is calculating a 3-day rolling average on that data frame. Now what I can do is run our magic command that's going to bring back that data frame into Insights. So I run that line of code, and if you watch up here, that's brought in that new layer. And if we look at the original, this was the data set, if you remember, I passed through with these 4 different fields in it. So this now has my rolling average, which is what I added in there, the new field, and it has that calculation in there that's giving me that new rolling average on that data set. So now I could take the number of cases, the rolling average, the state, and if you remember, we have that combo chart that allows us to visualize all of that information together. So now we can see that comparison between those two of the difference between the rolling average, which is just kind of smoothing that off a little bit, taking into account the fact that certain countries may not have reported the number of cases on exactly the same day. So it just kind of smooths out maybe some of the problems that may be seen within that data collection. Remember, we can change this visualization with a single click. So now I can compare numerically. Now we're able to see that there is really a subtle difference between those sets of values that we're seeing. So that's getting going with our Python code in that case. This does mean that we can extend it in all sorts of ways. So in this case, we've actually brought in a CHIME model. So this was a model created by University of Washington, and this calculates the amount of beds that may be needed in the case of the COVID-19. So we slightly adapted that script, but it still calls in exactly all of their code. And you'll see that once you've run the script, it actually stays within that workbook. So you're able to open up that code, and you can see where I've run this, and you're able to, I can just rerun this again. So this will be running that code. And this, of course, can be typed in directly here, or I can bring it in from a notebook or already a Python script that I've already written. And I can bring in my data sets to this. So you'll see here, this is where I need to bring in the different fields that I would want to put in to run this. So it doesn't have to be an entire data set. I can bring in individual fields that I'm passing through to that data set. So just drag those individual fields in there, run that. You'll see this is now running that data set, and I can then bring that layer back in. I don't need to wait for it to be completed, it's going to automatically queue that information for me. And you see, that's brought that result back in again. And now what I can do is I can use that join that back to Florida on that county name. And now you will see if I visualize those different counties, let's do it by county name on the map. Need that one. And now I will be able to see, if I can remember which field, my date, status, and value. If I put those on my chart, I should now be able to click around these different counties. And if I do something like enabling the cross filters, this is going to interact and change. So rather than doing a selection, this is doing a filter. And you will see that each one of those, it's very subtle, but you'll see each one of those is giving that new result for all of those counties. And you'll see how quickly that had been calculated for us in using that Python code. So now we're able to extend something that was previously just doing it for one of the counties. We've extended that so that you can iterate across all of the counties, in this case in Florida. You can also extend it so that you can run, in this case, I've run some some R packages, sorry. And what you can do in that case is you can actually bring in the visualization. So you can do that with both Python and R. So it doesn't have to be the results of your analysis that you're bringing in. It can actually be the code, the visualizations that you're bringing back in. So let me just run one of those as I'm speaking. So yeah, so if you want to create visualizations within Python or R, and are not able to do those within Insights itself, then you can create those visualizations in Python and R and actually bring those back into Insights itself. So this is setting up EpiModel and running those different calculations. So you see, if I get that, you'll see that's a new visual, and you'll see that I was able to bring that card back in, and that is now showing me that new visualization that I created within R in this case. So then I'm able to bring in all of these different visualizations and say these are from an EpiModel that we've run. So that's using everything within Python and R, sending your data to and from. One thing I did want to show before we go is I'm going to jump back to that tab in which we did that analysis of the Kenya data set. And I want to show you the workflow, the analysis view. So you'll see I'm up on the top of that page there. I can switch to that, and that is now showing me everything. So some things I'd already done up front and some things I've done live, and you'll see that that has created that entire workflow for us. So not only is this showing me what I've done to get to that analysis, but this is actually a model that I can share out with other people. So I can share that as a model. I can share this entire thing as a page. If I've shared it as a model, I can update that. Other people can then input their own fields. It doesn't have to have the same data set, the same fields or whatever. But what that means is you can have a standard approach. So you can have experts who design these models, create them, give it to somebody else who can then just rerun that analysis without having necessarily the skill set to create them. Or it could be a case of every month you want to rerun the same analysis and with new data and see the results. That's another effective way that you can use those models. So you can also share out all of these pages. These are more than just doing your analysis. We've tried to make the sharing of results as close to doing the analysis as possible. So it's not like you have to rebuild everything. It's simply a case of share as. You can share that page, that model. You can add in a theme. So if you want to add in your own kind of, Women in GIS Kenya at the top, you can do exactly that. And then you can add in that and then as I say, you just share that out. What people will see is everything except that data pane. So they will see all of that. They will be able to use those filter widgets that I added in. They will be able to see all of that interactivity that you have between all of the cards, but they're not able to access this piece. They're not able to advance the analysis in that sense that you were able to do it. So it's that kind of ability to quickly share to other people, to say either this is my final report, in which case you can spend hours tidying it up, changing all the colors, changing your fonts, changing the labels on all of the cards, getting rid of the headers and things. Or it could be a case of just sharing it as it is and sharing it within your organization, saying, what do you think? Is there something else that we should be doing, or something else that we should be looking at? So that,
Linda, it's also a question of transparency, right? Because rather than just showing a result, you'll be able to say, here's the result and here's how we reached the result, and people can dig into it and they can see your assumptions and your data.
Absolutely. Yes, that's a very good
excellent
point. Yes. So I think that's everything I have to show today, but I'm very happy to take some questions if there are any.
Kindly unmute your mic if you have a question, and then you can go ahead and ask the question.
Stunned silence.
Hi, thank you so much for the presentation. It was really lovely. One quick question I wanted to ask. As a non-Windows user, how can I use Arc Insights? I have most of my environment is in a Docker container, and I want to find out if there's a way that I can link it to Arc Insights to do this kind of visualizations. I use a lot of R notebooks and Python, and I'm just wondering if there's an external way. I saw there's a Docker deployment, but is it possible for me to extend my own Docker container using that deployment method?
Wow, that's a good question. I'm going to say I think so. I mean, we are a web interface, so essentially it doesn't have to be Windows. Our desktop version works on Mac and Windows, so that's definitely not a restriction. We actually deploy our stuff within the cloud itself at Esri using Docker, so certainly it can be done. We are a part of enterprise and online for ArcGIS, so you have to have access to those two features. So as long as you have access and licensing for those, you can certainly connect to your own setup of Python and R. As I say, that's exactly what we connect to. So yes, you can extend it in that way. So it's just there, as long as you have access to Insights itself, then yes.
So I need to have an enterprise license to access.
You do need to have an ArcGIS Insights license. It can be either the online license or the enterprise license. Yeah.
Okay. Thank you.
Maybe another question. Is there a guide online on how to link the different libraries? Like, how do I bring in R and Python? Is there a guide somewhere that I can use to do that?
Sure.
To extend my, okay.
So there absolutely is. Let me just go to that page. There you go. So this is our GitHub page, Insight Scripting Guide, and this steps you through, I just scroll down, exactly that process. So they're just deployed with either Anaconda or Docker. It's one or the other. You don't need both. And that is just setting up that connection to that gateway. And it's a simple case of just stepping through all of those and setting up how you do that connections. That's it up to that point. From here on in, it's just the features that it gives you. But we also explain exactly how that's working in terms of the setup if you have different connections that you want to have in terms of your security. So that will show you all of those details in there.
So in the chat window, someone asked how can they obtain Insights online licenses? I would say, of course, contact the Esri Eastern Africa office, and they can tell you the options. Depends upon where you're working and what types of things you're doing. I also just typed in, or I pasted in a link to some free courses on the site, which is called learn.arcgis.com. And there are several mini courses using Insights, so you can jump in and start playing with it.
Yeah, we've also got a few blogs out there as well, some that step through the Chime model. That's another source of information there.
I might just add that if people are thinking about career options, this is an interesting avenue to consider, because as you're well aware, people are studying GIS all over the place. But to distinguish yourself, this is a sort of an interesting way of going about GIS, doing analysis for commercial entities or for governments that are looking to drill right into particular questions and are not, let's say, working on traditional GIS projects, which, where they'd be concerned about centimeter accuracy and all kinds of data conversion, etc. This is sort of getting right into the analysis part, which could be interesting for some of you.
Yeah, it's definitely sort of sits in that intersection between the kind of BI world and GIS and tries to sort of combine, hopefully, the best of both of those worlds.
Any other final questions for Linda? If not, Caroline, maybe you want to wrap up.
So if there aren't any questions, I'm going to wind up.
Okay.
Linda, do you mind just unsharing your screen for a couple of minutes?
Absolutely.
Oh, there's actually a question on the chat box. Someone has just asked, can you save and export your work?
Yes, absolutely. You can save any of those workbooks. You can save any of the result data sets, and it's exactly the same in terms of exporting. You can export them to CSVs, you can share them back to your organization, and you can do the same with your workbooks or the results of your analysis. So yeah, everything.
Okay, so thank you so much, Linda and Michael, for making this happen. Thank you for everyone who's attended this webinar. So just a couple of takeaways. So we are officially launching the Data Visualization Challenge for Teenage Pregnancies. So we normally have challenges every quarter that focuses on issues that affect women and girls in Kenya. So the previous one was actually Cervical Cancer Awareness Month. And for that, we actually shared a data set with our community to explore patterns within the data and what therapy methods women locally prefer and why they prefer those methods. And then at the end of it, we actually link it with people within that space. So in light of what's happening with COVID and how it's deepening pre-existing inequalities in Kenya in terms of increase in teenage pregnancies, like we have seen, so we actually want our community to explore that. So the media has actually been reporting that there's an increase in teenage pregnancies. So we'll release this data to our community, and we are officially launching it today. We'll actually send the data set to everyone within this webinar and also to our mailing list to just explore that data set. You're also open to use other additional data files to actually understand maybe socioeconomic variables that actually impact or have an effect on teenage pregnancies across the country. So yeah, so today we are officially launching the challenge. We'll officially start it on 29th June, but the dataset will be shared before that. And we normally run the challenges for a month. So the challenge will end on 29th. You're open to explore any tools that would work for you, including Insights and any other tool you prefer to use in the visualization. The dataset will include data from 2011. That's when DHS was officially launched in Kenya. That's the program that actually records such cases within the country. So we will share that data set. So yes, so this is to just say that anyone who's been on this webinar is officially a part of our Teenage Pregnancies Data Viz Challenge, which is our second quarter visualization challenge. So also within this, I want to recognize the core team at Women in GIS Kenya. Thank you so much for making this happen. Thank you everyone, to all the participants who are present, all the 39 of you. We are so excited to have you on board. And after this, we actually have the next After Office Hours series, which will focus on using R for spatial data science. So we'll basically be extending this series going forward. Thank you so much for being a part of this. So yeah, so that's it. You can definitely join our community through a couple of ways, which is available on our website. One of the ways is spreading the word on social media or across your networks. The other bit is becoming a member. And when you become a member, then that means you're officially open to running the events, running the challenges, or deciding what arm of the initiative you'd want to run. You can also host an event with us, or you can become a volunteer. So all this is available on our website. You can sign up and do any of this. Thank you so much. Yeah, so that's it. That's the end of today's webinar. Thank you. So you can reach out to us on the numbers on the screen, and also to our official email address, which is info@wigis.co.ke, or the Gmail one. That's it.
So yeah, I hope you liked that content and learned a lot. Let us know in the comments below what you learned, and which other things you would like to explore, which other technologies you would like us to present on as webinars. If you'd like to know more about our work, check in the description box below for a link to our website, where you can learn about the projects that we are pursuing, the data visualization challenges that we are currently running, as well as the next webinar session that is coming up. So if you like this video and you like this kind of content, be sure to like, subscribe, and also share with your friends so that they may also learn from this. Yeah, see you around and have a great day. Bye.